my name is Tanner Berge, and we are Team 23018, University of Arizona Police Department and FBI Crisis Negotiation Team, Throwphone, and I study optical engineering.
My name is Reed Clark, and I study industrial engineering.
My name is John LaRue, and I study electrical and computer engineering.
My name is Thad Proper, and I study mechanical engineering.
And my name is Marcus Weiser, and I study mechanical engineering.
The University of Arizona Police Department and negotiators around the country have been trained in negotiation tactics and psychological know-how so that they can efficiently and effectively de-escalate ongoing crime scenes. They do this by employing a device called a throwphone, which allows negotiators to talk to suspects from a safe distance, as well as provide video surveillance of the suspect's immediate surrounding. The video surveillance provides first responders, both UAPD and SWAT, with critical information of the suspect's location, mood through body language, and if they are armed or not. And by being able to talk to the suspect, a police negotiator can use their years of training and education to de-escalate the crime scene without the need for violence. However, the current systems in use by police departments across the country are far overdue for an upgrade. Current systems are all wired, meaning that hundreds of yards of thick, reinforced cables need to be unwound in order to deploy the throwphone. On the end of the cable is a reinforced box that contains a receiver in which the suspect can use to talk to negotiators. But this requires unnecessary hindrances. Suspects have to open the box and hold the receiver to their ear, which our sponsor has communicated is not often inviting for suspects. The box is also ominous and heavy. It is solid black and weighs 30 pounds. Our task is to build a modern throwphone that makes police negotiators' job as easy as possible.
The strength of our team is in our effective communication with our sponsor and understanding of the end user's needs. Because Joe is a police negotiator himself, we have gotten a first-hand account on how the current equipment operates and its shortcomings. Our team has gotten the opportunity to present and receive feedback about our design at an FBI negotiator training school. During this training, we gave a brief presentation about our design process and show what was then the concept of our first prototype. This was valuable for our team because it gave us further interaction with the end users. Because of these things, our team is confident that we have provided a design that satisfies our sponsor's needs.
We considered multiple different designs and different concepts and their uses. From a trade study, the team determined that a simple Nokia-style phone was best, and then we had the idea of adding handles to this design as a piece of social engineering. Negotiators are trained to keep their right hand free at all times, so they have quick access to their firearm. Using an inverse psychology, we want to provide suspects with something to hold in both hands to keep their hands occupied from holding a weapon. The ability to include these handles to assist in the human side of the de-escalation process sent this design far ahead of the others.
Here is the heart of our solution and how it works, starting with the audio subsystem. The brain of this subsystem is the Raspberry Pi, which interfaces with all the other components as you can see here. It receives power from this battery, which powers the whole system. This is a transceiver. It allows the command module, which is the device police negotiators will use, to communicate with the throwphone. This transceiver utilizes a subscriber identity module, or SIM card, like the one in our cell phones, to connect to a 4G mobile network, allowing it to communicate with the command module effectively and from a long distance. It will receive audio data sent by the throwphone and processes it via the Global System for Mobile Communications module, or GSM module for short, sending the data as an output to the headset. The throwphone utilizes a cell phone that will automatically accept a call from the Raspberry Pi from the command module. These speakers in the throwphone produce audio at 90 decibels from 1 foot away without the suspect ever interacting with the throwphone. This assures that they always hear the voice of the police negotiator even if they don't want to. This setup allows both the police negotiator and suspect to communicate over a full duplex channel, meaning that they can speak and listen to one another simultaneously. This is important so that negotiators never miss what the suspect is saying.
And in this subsystem, the throwphone will transmit video data to the command module. We have 3 155-degree field of view cameras on the phone that connects to a video switch. These high-quality cameras are normally used on racing drones and boast excellent low-light performance. The cameras are connected to this multi-viewer, which allows the police negotiator to switch camera perspectives from this controller. The controller connects to the multi-viewer via this receiver. The multi-viewer sends the video stream of the chosen camera to this antenna. The cameras, multi-viewer, receiver, and antenna are all powered by this 5-volt battery. The antenna transmits the video signal, which can be picked up by this monitor, which also contains a video receiver. This will be stationed by the command module for the police negotiator team to use. Additionally, the video signal can be picked up by these receivers for SWAT to access the video feed. We want the SWAT teams to be able to see into the scene so they can discern things like where the suspect is, how agitated they are, and whether or not they are armed. This subsystem runs parallel to the audio system so that both operate individually.
The command module contains a transceiver, microphone, and Raspberry Pi for audio, and a receiver with a monitor for the video. Instead of speakers, the police negotiators will plug in headsets to listen to the suspect. The board on top is designed by our team for this project to make the command module easy to interface with. This is all housed in a hard case, which is very familiar to the police force as it is a similar style of case that they have used in the past. And there are no cameras on this device. A switch here allows police negotiators to turn on and off microphones to control when the suspect is able to hear him. Notice that there is no switch like this on the throw phone. This is intentional because police negotiators want to be able to hear everything that is going on with the suspect at all times. Because this device will literally be thrown through a window, it is important that all these electrical components are housed in a case that will keep them operational and hidden. This is one part of the two cases the team has designed. This half holds all components in place and protects them from direct drops or strikes. On this side here, we have vents to allow airflow and system cooling to prevent damage to the components due to overheating. And seen here on the front is a compartment for the antenna, which provides functionality of audio and video transmission. The compartment is on the outside of the case so that there is no interference from the signal trying to pass through the material. Throughout are holes designed to fit the cameras seen here and here. Covering these holes is a thin sheet of acrylic to prevent the camera lenses from being scratched. These vents here and here are for the microphone inputs, and these are mounts for the Raspberry Pi. Here is where the battery will be attached. You can also see that there are also holes in the wall of the case to allow for cables to run through to the antennas and cameras.
This inner case is then protected by a rubbery outer case. This is made of a soft plastic that absorbs the shock when the device is thrown. You can see that the holes for the cameras align with that of the inner case, as do the vents. This outer case is composed of 3 different parts that wrap around the inner housing and are secured with special security screws. The largest piece has the aforementioned handles attached to it. The handles are designed to occupy the suspect's hands and keep them from being able to wield a weapon. This is something that really excited our sponsor. He called it a stroke of brilliance. This human factors engineering shows that our team is dedicated to the end user and their goal to de-escalate a crime scene. To test whether or not people unfamiliar with the device would respond to holding the handles, we conducted some interviews with people who knew nothing of our project.
Here's the team's verification flowdown that shows what we will be testing to ensure that our design satisfies our sponsors' needs and wants. By verifying these things, we will prove the usefulness of our design to our sponsor and the design's ability to de-escalate a crime scene utilizing human factors engineering. Here's an example testing the range of the video system. This is the recorded video from the maximum distance we can transmit video.
The quantitative results of these verification tests show the margin of our design, or how well our design performs. Here you can see that our design has high margin for our sponsor's requirements, meaning that the project has been a success.